Hi everyone, this is lesson 5.1 and we are going to do some practice problems related to the activity that you did a few days ago. So what you learned is the mid-segment theorem, which says that, a mid-segment, first of all, is a segment that we can go back maybe a few slides, is a segment that connects the midpoints of two sides of a triangle. And there would be three mid-segments within a triangle as you drew from the GeoGebra activity. And so if it's a midpoint, look at point D here. If it's a midpoint, then it bisects the side AB. So AD and DB would be congruent and half of the length of AB. And so a mid-segment has two properties, that a mid-segment is also half of the length of the opposite side. So it would be, and you already wrote this down, so you don't need to write this down again unless you want to. But DE is 1/2 of AC, the length of AC, or that if you multiply both sides by 2, then you would get 2 of the length of DE is equal to AC. Okay, and then also that the mid-segment is parallel to its opposite side, all right? So here for some practice problems, and you did questions like this also, so you don't need to write this down, but just to review. So here x would be 14 because ED is the mid-segment and it's twice the mid-segment. Here x would be equal to 8 because they told us that D is a mid-segment, so E must be a midpoint. Therefore, these two segments are congruent. And then here x is going to be half of 32, so 17. Okay, also, for the previous slide, we look at here a coordinate plane. So this one you would want to write down. So triangle ABC has vertices 0, 2, 2, 10, and 12, 0. So let's graph those points. So 0, 2, 2, 10. So 0, 2, 2, 10. And 12, 0. We'll say that's 12. This is 11, that's 12. Okay, and then I'm going to connect those. So here's like a little coordinate proof of the mid-segment theorem. All right, so there's our triangle. And number 1 says find the midpoint D of AB and E of BC. So let's go ahead and use the midpoint theorem or the midpoint formula then. There is a way that you can kind of do it just with counting with a slope, and you can do that if you want, but I'm going to show, the way to do it with the midpoint theorem or formula. So the midpoint formula says add the x's and divide by 2, and then add the y's and divide by 2. So point D will be of AB. So add the x's, 0 plus 2 is 2, and then 2 plus 10 is 12 over 2. So the point D will be at 1, 6. Okay, and if you drew a good line, it should kind of match up with the line you drew. So that would be your midpoint D, right? And we'll do the same thing with BC. So for BC, point E is the midpoint, and the x coordinate, add the x's together. 2 plus 12 is 14. Divide by 2 is 7. Just going to write 7 there to save space. And then 10 plus 0 is 10. Divided by 2 is 5. So E, the midpoint of BC, is at 7, 5. 7, 5. There it is. And then let's go ahead and connect the points for D and E, and that would be the midpoint, or the mid-segment. So now we also know that the mid-segment is parallel to the opposite side. So it would be parallel to AC. So here it asks us to show that DE is parallel to AC. So one thing, if you knew what the angle measures were, is you could use that in corresponding angles. But another way with coordinate geometry is to use the slopes to prove that they're parallel. So what's the slope of AC? So actually, hold on. We'll do M sub AC and then M sub DE. So I am just going to use rise over run. So to get from A to C, we would go down 2 and over 12. So that would be down 2 over 12, negative 1/6. So the slope of, I think this is supposed to say DE, should be the same. So we would go down 1 over 6, because this is at 7. So down 1 over 6. So we now prove that those two lines are parallel by proving that their slopes are the same. And then show that the length of DE is twice the length of AC. So for that, we would need to use the distance formula. Okay, so DE, we found the points over here, so we'll do the distance formula between them. So 7 minus 1 squared plus 5 minus 6 squared, and this would be 36. 6 squared is 36 plus 1 squared is 1, because when you square negative, the negative cancels. So this would be the square root of 37. And I'm not even going to bother typing that into my calculator because, well, actually we might, since we're not proving that they're equal, we're proving that this is twice that. So let's find AC. So AC would be, using the points up here, 12 minus 0 is just 12, plus 0 minus 10 is just 10 squared. So this would be 144 plus 100, so 244. Now, this is what I'm talking about. So right now, it doesn't look like 37 is twice 224, right? But we have to evaluate this actual square roots. So if you type those into your calculator, let's see if I can bring up my calculator here. All right, you guys, sorry, I had to restart the video to figure out where I messed up. So apparently this is supposed to be not 10, but 2, because it's 0 minus 2. Okay, so that makes a little bit more sense. So 144 plus 4 is 148. So you take your calculator and you do 30 square root of 37 times 2, and then you would do the square root of 148. Okay, there we go. So these two match up to 12.165. So this is, if you multiply it by 2, you get 12.17, and then this is 12.17. All right, so sorry about that. Let's do a couple more problems. How about this one? So if DE equals 4x plus 5, and we know that D, E, F are midpoints, so these are midsegments. So DF here is 4x plus 5, and then GJ is 3x plus 25. So the way we would set up our equation then, we could do 2 times the length of DE equals the length of GJ. So we would do 2 times 4x plus 5 equals 3x plus 25. All right, so distribute the 2, 8x plus 10. Combine like terms or move terms over. So we would get 5x equals 15, x equals 3. Plug 3 back in for DE. And you get 4 times 3 is 12 plus 5 is 17. Right, and then for the other one, it's telling us EF, and then it's telling us GH, and then it's asking for what EF is. Oh, wait. Yes, EF. So that's kind of the same thing. Let's go ahead to number 6, because that's a little bit different. So it tells us that it tells us hj. So where's hj at? Is the length of this whole thing 8x minus 2, and then df is 2x plus 11. And then it says to find he. So it says to find this segment. Well, that should be the same as 2x plus 11, since df is half the length of this whole thing. So really, once you get x, you can just plug it into 2x plus 11, and then that would be the same thing as he. Okay, so I'm not going to walk you through that question. It's just simple algebra. You would just set it up as 8x minus 2 equals 2 times 2x plus 11, and then solve for x. Okay. And then number 7 is kind of the same deal. So it says it gives you hd and dg. So hd and dg. So actually for that one, you're going to set these to equal to each other. And then it wants you to find EF. Well, EF would be that guy, and all three of those segments are congruent to each other. So to find EF, you just plug whatever you get for X back into either one of these, and you would get the answer. And once again, I'm not going to waste your time solving this simple algebra problem. I will let you do it on your own. All right, so that concludes this lesson, and I hope you have a great day.